What we'll be doing here today is reviewing some of the more common proposed solutions to the Fermi Paradox, which is essentially the question, if there are aliens, why can't we see them? And we'll look over some of the strengths and weaknesses of those various solutions. There are a lot of them, so we'll be moving fairly quickly over each, and this is still going to take quite a while. To help with that, we'll also loosely categorize them into some groups. No grouping is ever going to be really ideal, but they are helpful, so here are the ones I've selected. Category 1. Alien civilizations are incredibly uncommon. There are no alien civilizations, or they are so incredibly rare that most galaxies have never spawned even one. Category 2. They are common, but hard to see. They are alien civilizations, but we cannot hear them. Category 3. They exist and are not hard to see. We interact with them routinely, but most or all don't realize it. And Category 4 will be our miscellaneous category. A less formal way of looking at those categories would be Category 1, we can't see aliens because they don't exist. Category 2, we can't see them because we're not looking hard enough or in the right way. Category 3, we can't see them because we are being tricked or tricking ourselves. And Category 4, we have a massive flaw in our logic where this paradox is concerned. Category 1 we'll cover pretty quickly because first, I recently did a lengthy video discussing it in enormous detail, and second, it's the camp I loosely align to, so I'm not great at criticizing it. A little bit of internal bias. But inside Category 1, you have basically three subdivisions. 1A, the conditions needed to achieve complex life are much less common than we assume. 1B, intelligence is not a common outcome of evolution, or intelligence does not automatically lead to technological civilizations. And 1C, intelligence in this universe does not occur naturally at all. Category 1A is fairly broad, but essentially comes down to the notion of great filters and the rare earth hypothesis. In the Fermi Paradox, a great filter is something which assumes a lot of steps on the road to becoming a technological civilization and staying there long enough to be seen and heard. Sometimes this is a single filter, like an assumption all or virtually all civilizations nuke themselves out of existence within a century of making a nuclear bomb. But just as often, it can be a series of filters that each have a large chance of enduring the journey to technological civilizations. As an example, 1 in 10 stars can host habitable planets, 1 in 10 of those worlds develop life, 1/10 of those get complex life, 1/10 of those luck out on some cataclysm or change that wipes out complex life too frequently to go further, 1/10 develop life with significant brains, 1/10 of those achieve intelligence, and 1/10 of those develop technology, and 1/10 of those avoid wiping themselves out. That's 8 1/10ths, or 1 in 100 million, which would result in several thousand of these civilizations in one galaxy alone. But if the odds were, say, 1/100th instead of 1/10th, then that would be not several thousand civilizations per galaxy, but one civilization per several thousand galaxies, and that would explain why we hadn't detected them yet. There's also potential criteria that might be uncommon but required for complex life, like having a large moon or a Jupiter to vacuum up space debris so it doesn't rain down on the planet regularly, or the conditions on the planet are very prone to toppling out of habitability. Here quickly are some of those, and again, we won't really be challenging these as much as we will in other categories. Planetary habitable zones are narrow and move as star ages. We classify habitable zones basically as where liquid water can exist on something of near Earth size, but that's a pretty big guess, and planets don't move in circular orbits but ellipses anyway. Planets might ice over or tilt into runaway greenhouse effects far more easily than we currently assume. Additionally, the luminosity of stars changes over time. They get brighter, they get hotter. That pushes the habitable zone outward. Many also fluctuate in brightness much more than our sun, and give off regular deluges of light like XUV radiation, which is inimical to life, not just Earth life, but basically any life that's based on regular chemistry, because that type of radiation breaks chemical bonds. Next, Jovian planets might be rare. This notion that a planet will get bombarded by asteroids without some other larger body around to pull those in is a fairly valid one, but the idea has fallen out of favor as a strong filter because we've detected so many exoplanets in other solar systems that parallel Jupiter in size as well as location and could perform that vacuum cleaner function. Large moons are rare. Earth's own moon is very nearly a double planet, and it has a huge impact on our environment in terms of tides, weather, axial tilt, and so on. It is usually assumed that early land life evolved from creatures that evolved to handle tide pools. No big moons, no tides. Geological events have to be just right for complex life. A planet with no volcanoes or plate tectonics is going to erode away into a massive, flat mud ball, or a landless sea, which is not well suited for diverse complex life, let alone tool-using life. And we have many others. Cells with nuclei develop very rarely, specialized organisms with distinct organs are not common, galaxies are volatile places which often expose worlds to sterilizing blasts of radiation, and so on. Individually, one of these might be a great filter, that fewer than 1 in a billion pass, or they may each just be something that just drops the odds of life by an order of magnitude at each step, which adds up to making complex life very rare. The big flaw here is that we really just don't know the odds, and none of them seem to work as a single great filter. None of those really seem like 1 in a billion type things, and many are not even indicated to be less likely than not, let alone highly improbable. So stacking them all into a sequence that makes complex life rare is sort of like assuming the worst case scenario has happened at each step along the way. Category 1b. That intelligence or technological civilizations are rare isn't necessarily separate from Category 1a, since it can be additional layers of filtering, but it is distinct in that it argues that technological civilizations may be a freak anomaly and not an inevitable end goal of evolution. Now, of course, evolution does not have end goals, but it does tend to produce increased complexity and sophistication, and we often assume intelligence to be one of those, and technology to be inevitable from that. The other chunk of 1b is that technological civilizations might be uncommon because they inevitably take themselves out through nukes, biological warfare, runaway self-replicating machines, and so on. 1b is complicated because intelligence is a bit hard to define. Humans are the only intelligent life on Earth, but of course we are not. Besides other primates like chimpanzees, we have cats, dogs, dolphins, elephants, pigs, raccoons, and many other creatures who we are tens of millions of years away from in terms of a common evolutionary ancestor, and yet they have clear intelligence, problem-solving abilities, and even tool use or building skills. Many have had this level of intelligence for a very, very long time, even on geological timelines, and yet have never carried it any further. Now, many assume humans just hit the complex tool use level first, and that if we disappeared, eventually one of them would get there, but our brains, with the large folded forebrain and the cerebral cortex, the large cerebral cortex, is a pretty big jump, and there are a lot of little factors in our biology that probably contributed to our rise as a technological civilization, which may be peculiar or sometimes even harmful to us or other animals that might develop them. We have large heads with skulls that are so soft so they can expand later, and this is very dangerous for live birth. Additionally, that soft skull probably is a big factor in the plasticity of our brains, which is associated to learning, and a need for learning since you don't have as many wild instincts. It's not just that you can learn, it's that you must learn to survive. We are omnivores. Cats aren't. They could probably never develop specialist societies because they can't support a dense population through agriculture, and everything they eat is terrified of them, making it probably fairly hard to get good at tending livestock. Even if you get the brain and the tool use, which we've had for hundreds of thousands of years, you might not use technology much. We have fire, but that might not be popular. We cook our food, which allows us to store meat longer, and also lets us digest certain types of food better to derive more nutrient from it. A given creature might hate the taste of cooked food, or the oxygen content of their world might be a little higher. Higher oxygen content makes forest fires even more devastating than they already are. And it might make the very idea of keeping fire around with the tribe considered the equivalent of juggling hand grenades. It's so dangerous they don't want it around. Fire is dangerous as is, but it's exponentially more so as oxygen concentrations rise, and you need fire for technology. Some worlds, from different levels of tectonic activity or erosion, or just composition, might not have an easy time finding copper to make those forced metal tools from, limiting you to flint and wood, which cannot be used to make some tools well enough for them to really be better than just employing some old school method. Pottery will never develop if you don't have fire either. Plants with no seasons, or very mild ones, will not require a means of preserving food. Tidally locked worlds, which always have the same side pointing towards the sun, will never see stars, where life can live anyway, so they never develop astrology or astronomy. Or worlds might have thin clouds that block out the sky all the time. The world might not have large deposits of fossil fuels, so there's no industrial revolution, and so on. So essentially, Category 1b challenges the idea that evolution will inevitably spawn technology, and throws in the caveat that technology might also inevitably just kill off a world. That you might, no matter what you do, find yourself proceeding down a route of self-destruction. Its big flaw is that while we know evolution works, we really don't have a clue about the probabilities involved on a given step, nor do we know if we might stumble across some bit of seemingly great technology that amounts to signing a suicide contract by using it. Self-replicating robots, a power source that makes fusion look shoddy but blows up a planet after a few years of operation, and so on. Category 1c, that intelligence in this universe does not occur naturally, covers more of the supernatural cases, though also includes an extreme version of 1b, that a freak anomaly had to occur, rather than an improbable but natural evolutionary jump. If you've ever heard of a Boltzmann brain, essentially the notion that over a long enough time in a large enough space, random events would just assemble a computer out of nothing, not through evolution, but just freak odds, the things comes together and is a working computer, just right out of dust. That's basically the reasoning there. But this category includes God did it, or aliens in a prior universe with different rules made this one, or the neo-equivalent that we're running a simulation of a universe where the laws differ from the simulating universe, and intelligence would not naturally develop, so they tweaked us specifically so it would. If we wanted to simulate a universe on a giant computer where, say, the speed of light was 10% higher, and we found out that life could actually exist, but just could not naturally evolve, that the steps to get there were just way too improbable, just too unlikely to occur, we might just throw them into a ready-made one to see what happened afterwards. 1C is not scientifically popular, but in truth many of the other solutions we'll see are much akin to it, so leaving it out would be unfair. It has the obvious flaw that there's no scientific evidence to support it, and that most versions are not internally provable. Meaning that while an outside force that did it can come down and say, "Hi, it's me, this is what I did," you can't, from inside that box, ever show what's going on. Internally, you cannot prove or disprove it. Even in the case of a Boltzmann brain, one that assembled complete from particles with no evolutionary steps, it would be on sound ground for such a creature to wonder if someone had made it, rather than assuming it was an astronomically improbable fluke event, even though it knows that that is actually possible. A clock can assemble naturally, the odds of this occurring are just so incredibly unlikely that you're going to wonder if there was some outside covert construction, and that's really not too absurd of a premise. So that's category 1. We don't see aliens because they are incredibly uncommon or don't even exist at all. Category 2. They are common but hard to see. They are alien civilizations, but we cannot hear them. This is where most of the argument about the Fermi Paradox goes on, and where we'll spend most of our time. It's harder to break into subcategories, but here are the major ones. 2A. They've got mouths, but we lack ears. Typically that just means they don't use radio for communication, and that's what we listen to. 2B. There just hasn't been enough time yet for us to hear them. 2C. They don't talk because they have no reason to. And 2D, they hide, intentionally. The biggest flaws going on in Category 2 are the mediocrity principle and the idea of exclusivity. The mediocrity principle we know. When you've only got one example of something, you should assume that it's probably a fairly normal or mediocre example of such things. It comes into Category 2 because frequently in this category we rely on choices and behavior of alien civilizations. They probably have little similarity to humans in many areas. They are literally alien. However, they also just as probably have that same alienness to each other. A given alien civilization might act in some way, but others won't, unless that behavior is exclusive. As an example, we can assume that no species that ever explores the stars or settles other worlds hasn't learned basic Newtonian physics. You need that to build rockets. You can't avoid seeing it in action very simplistically in space, even if you somehow got up there without it or evolved in an asteroid belt or deep space. There's no air friction interfering with basic processes up there, so we can say that space travel is exclusive to species who know Newtonian physics. However, while many people believe in the inevitability of social progress to some predetermined and universal system of behavior, and often have some good arguments to back that, it's pretty obvious that just among humans it is possible to get up into space with many different types of cultures. So it is hard to argue that space travel is exclusive to democracies or communist civilizations, or ones which have curbed population growth or given up on war, etc. Space travel would seem to be non-exclusive of democracy or human rights or unchecked population growth, and so on. That will come up a lot because, as we discussed in the prior video, the Dyson dilemma, if a species is prone to keep growing in numbers and territory, even if it's a very slow growth, even if they are fairly rare, they will soon become the supermajority of intelligent life in that area. So you'll hear me reference non-exclusivity with a lot of the Category 2 solutions, along with the mediocrity principle. So Category 2A. They have mouths, but we have no ears to listen. Again, this typically means that they don't use radio for communication, which is what groups like SETI listen for. This could include something that's faster than light or even instantaneous, or something like neutrinos that just go right through everything that we have right now, but could conceivably be detected much better by superior technology, or even just that they don't use omnidirectional signals, which are very wasteful in most cases, especially for long-distance communication between two spots. Even if you've got 100 colony systems around your homeworld, they are such small targets that it might make more sense to send a tight beam to each system rather than one big omnidirectional signal. They talk, but we don't hear them because they're talking in sign language, and we're listening with our ears, basically. This is a pretty solid argument, but it suffers from a few problems. First, if we don't know what kind of new physics they are using to talk faster than light, we're not just assuming some sort of science we don't have. We're also assuming behavior based around something we don't know anything about. We have light-speed communication, we have the internet, but people still use fax machines and even snail mail. We have TV, but AM radio remains strong. The ability to send instant messages across the stars could be much more expensive, byte for byte, than a radio signal, and if so, you'd still use that on your planet because radio is fast enough. We don't know how this thing, which breaks known physical laws, would operate, so it's a huge jump to say that's what's going on. Second, this hits the problem in the Dyson dilemma. We may well not be able to hear signals from an alien homeworld, even if they were in mundane radio, but if they are expansionist, we don't need to listen for their homeworld's radio signals, we just need to listen for their colonies. Biological life tends to grow with time, when it has the resources to do so and no external pressure stopping them or hunting them. Over a long enough period of time, you don't need to look thousands of light years away for alien radio signals, you just need to look at any star nearby because they've colonized it or someone else did. Indeed, there's no obvious reason you need to listen for radio to see those nearby worlds either, because they will probably be tapping their star for energy by surrounding it with solar collectors and artificial habitats, often called Dyson Spheres or Dyson Swarms. The Dyson dilemma basically says it doesn't matter if we can hear their phone, because any pro-growth civilization decently older than us is going to have surrounded their star and many nearby ones with Dyson Spheres or Dyson Swarms and just keep slowly expanding so that you can't miss it. And this is where non-exclusivity comes in. Unless one can show that the ability to engage in serious expansion of your own planet is exclusive to a species which are no growth, or destined to be no growth after a period of time, then it would only take one species, or even just a subculture of that species that was pro-growth, to ensure this expansion happened. Now, as we mentioned earlier, many people do believe certain behaviors are inevitable as a part of social progress. If you believe that includes no growth even when you can, then Category 2A is very reasonable. If you believe it is not inevitable for all intelligent life, then 2A, and most of Category 2 in general, is just shot down. And again, watch the other video if you want that explained in detail. This also discusses the problem where civilizations kill themselves off in short order, which again hits the idea of non-exclusivity, unless you subscribe to that being an inevitable event by any technological species. We will assume here that inevitable no-growth or inevitable extinction are not the case. If you feel otherwise, Category 2 is good for Fermi Paradox solutions. Category 2B. There just hasn't been enough time for us to hear them yet. This theory holds that technological life is a very recent development. There just hasn't been enough time for aliens to develop, expand, and for signals to reach us. We haven't been listening long enough to pick up some of the weaker signals. Indeed, we might be the first intelligent life form, or if they are a rather rare type of thing, this first one in the galaxy, and the guys at Andromeda beat us to the punch by 100,000 years, but no signal or sign of mega engineering like Dyson Spheres would have gotten here 2 million light years away as of now. Life couldn't evolve to intelligence until relatively recently. Now, the problem here is simply scale. There is good reason to believe that complex life might be something that could only exist relatively recently. It takes several generations of stars to produce metals, many supernova events, and those same events can sterilize nearby worlds. The problem is that relatively recently generally means in the last couple billion years. There are over 1 million stars within 500 light years of us. The whole galaxy, with 500 billion stars, is within 100,000 light years of us. And there are many galaxies a few million to maybe 10 million light years of us, with trillions of stars amongst them. Those are immense distances with correspondingly immense times for signals to travel to, and even larger ones for ships that can't go faster than light, or even at a good percent of light, to travel. But the problem is, as we said, scale. 1,000 years, 1,000,000 years, or even 10 million years, the often cited figure for a whole galaxy to be colonized without any new physics, is just a tiny, tiny number compared to even 1 billion years, which, based on what we know of the universe and life, ought to be the conservative and late timeline for technological civilizations to have arisen. By the mediocrity principle, we must assume that, barring evidence to the contrary, even if no worlds that gave birth to life are older than our star, that roughly half will have beaten us to technology by several million years at least. And again, there's no reason we know of why stars a billion years older, but otherwise identical to our own, wouldn't have gotten technology a billion years ahead of us. So if we're not assuming self-destruction or zero growth are inevitable results of technology and social progress, we just have not got the justification for the idea that there's not been enough time for signals to have gotten to us yet, because they've had billions of years to broadcast time, and billions of years to expand outward from their homeworld towards us to make those signals easier to see with less time lag. Category 2C. They don't talk because they have no reason to do so. Examples here would be that they just don't see a benefit to talking to other aliens, and maybe even consider it harmful, as we'll discuss with interdiction later in Category 4. Maybe they've become some single machine intelligence that gains little from going elsewhere and just doesn't put a value on cultural knowledge. Maybe they've all retreated to a simulated universe, say virtual reality utopia, and it's much more interesting to them than some 1,000-year-long phone conversation. Lots of options here for why they wouldn't want to talk. But they all share this common problem. This one encounters the same problems raised in the Dyson dilemma, that we don't need to hear their phones to see they are there if they've been expanding. But it also double dips into non-exclusivity by assuming none of these aliens, who should all have as radically different behavior from each other as from us, don't feel a reason to chat with other aliens, even just to broadcast over and over again, "This area of space is ours, stay out, we don't want to talk to you, this is ours, stay out and we will leave you be, come in and we will blow you up, stay out, message repeats." It's already stretching a point to say all aliens aren't talkative, but to assume they don't even broadcast to deter accidental invasions is stretching common sense. Animals routinely mark their territory and vocally discourage incursions because fighting, if you don't have to, is dangerous, risky, and costs time and resources. Mediocrity principle tells us that animals on at least some other worlds probably do the same territorial markings, and non-exclusivity would suggest some aliens ought to have giant omnidirectional broadcast arrays just screaming "stay out," even if they are otherwise not chatty. There's also a reverse example of non-exclusivity here, of exclusivity, because while we can't say that intelligence is exclusive to creatures with curiosity, common sense would indicate that curiosity is not likely to be uncommon among technological civilizations. It's hard to imagine they wouldn't be curious by nature, let alone that this would be a universal rule. And unless they are afraid, then it doesn't have to be the whole species, just a handful of them who want to do this. We have no reason to think aliens are any more homogeneous in behavior and outlook than we are ourselves. And that takes us to Category 2D. Maybe they are afraid. Aliens don't talk, just listen, and actively hide because they are afraid of being seen and heard. This makes a lot of sense. We have a term called METI, the version of SETI, the search for extraterrestrial intelligence, which focuses on messaging to extraterrestrial intelligence, also called active SETI or positive SETI. METI, in which you intentionally broadcast to aliens, is unlike SETI, which passively listens for aliens. It's not very popular, it is very controversial even. Many SETI backers outright condemn it, will not support it, and I've even heard people suggest it should be considered a crime against humanity, as it's potentially telling hostile aliens how to find us. It wouldn't be too hard to imagine other aliens do exactly that, ban transmission, and maybe even hide more of their world so it looks uninhabited. Problem here is it also hits non-exclusivity. Now, one can argue that all aliens will come to the conclusion that passive listening, rather than broadcast, is the path of wisdom, but this breaks down over time even if it is true. Again, it has to be every member of a species doing it, since it would only take a few people to broadcast. But worse, they have to keep doing it. How long do you have to wait before you say, "Look, we've been listening to silence for 1,000,000 years, hiding here on our one planet for fear of drawing attention. Either no one is there, or they are, like us, just paranoid and hiding. Let's expand." And if someone replies, "Well, what if there is some galaxy-spanning species of xenophobes waiting to see us and jump on us?" Or what if they are killer robots in space quietly waiting for intelligence so they can kill it? You just reply, then they must be beyond stupid, because they could easily have investigated every single planet in the galaxy by now, and even ensured no life ever came to be on them in the first place. It just isn't that hard for a determined species capable of wiping us out to have found us in the first place. And this is pretty sound logic. Killer xenocidal robots, or species, make for good science fiction, but make just about no sense. If you were such a species, and could design long-lasting and self-repairing robots to purge the galaxy of alien life, why would you settle for leaving a few million outposts all within 100 or so light years of every world just to listen to the radio? Why not just sterilize every single world that could support life, and rinse and repeat every 100 million years? Or if it's just that you hate intelligent life, why even wait for radio signals? Why not just leave satellite telescopes near habitable worlds that would sit and stare at those worlds looking for any patterns at all? Pull up Google Earth sometime and zoom out till you can see many miles at once. Look at a natural area, like a national park. Then look at any area settled by man, city or farmland, that is very obvious and requires no radio signals to see, and you'll be able to detect civilizations that way long before they got radio. Now, in the face of that logic, it is hard to imagine a civilization, having thought of that, just staying hidden at home for millions of years, especially considering that by expanding, they'd have more resources to deal with an aggressor, more scientists to research weapons, more wars to build those weapons, multiple wars to be a safeguard against natural disasters or surprise attacks by other people's doomsday weapons. So while the idea that aliens just listen and don't talk is reasonable, the notion that they all do that, and that they keep doing it for hundreds of millions of years, really is not. That's it for Category 2. Again, fundamentally, the problems with Category 2 is that unless you believe extinction inevitably results from technology, or that all societies have to evolve in the same fashion, and not grow, Category 2 suffers from non-exclusivity. There's just no reason to think they'd all act like that, especially when there's many obvious downsides to doing so. That takes us to Category 3. In Category 3 we have they exist and are not hard to see. We interact with them routinely, but most or all don't realize it. And we'll break this down into 3 subcategories as well. 4 categories. 3A, aliens walk among us but hide themselves. 3B, aliens used to walk among us and helped us get technological. 3C, aliens are here but are so unrecognizable we just can't see them for what they are. And 3D, we are ourselves aliens. The big flaw in number 3 is just a lack of evidence. But as we discussed way back in Category 1C, just because something is very hard, or impossible even, to prove internally, does not mean it's wrong. Many, of course, do believe we have evidence of aliens walking among us, and while I think they're wrong, this wouldn't be complete if we left out one of the more popular groups of solutions to the Fermi Paradox, nor am I going to sit around here making fun of them or heaping scorn on them. It's enough, in my book, to say there's no hard evidence to back these solutions, with the caveat that, in fairness, most of the other solutions have the exact same problem, only difference being that we can actually gather evidence of stuff here on Earth or near Earth, and we can't get to other worlds yet to examine them. Decent logic with a lack of evidence because you can't get it yet gets a little bit more respect in my book than those where you can obtain evidence. 3A. They walk covertly among us. It is impossible to have been raised in modern times and not know a bunch of TV and movie examples of this, and again, evidence for it is either absent or considered by most to be dubious. Nothing else to say on that. 3B. They used to walk among us. Ancient alien astronauts helping us build the pyramids and other things has shown up in a lot of fiction, and again, we're all familiar with it. For this subcategory, there's tons of evidence, such as pyramids, but that evidence itself is disputed by arguments that we could and did build such things on our own. My only add-on to this is twofold. First, if they were willing to involve themselves back then, what changed to make them stop? And while all these examples here are things we could have done without any inclusions of stuff beyond us, like a lighthouse that ran on a passive nuclear reactor or advanced alloys we couldn't have made in that period. Second, and it's not an evidence-based argument, I don't like 3B because it demeans, in my eyes, the accomplishments of humanity and of the individuals whose efforts were a testament to themselves and humanity, because those didn't happen in a vacuum. That's not a logical evidence-based argument, but I think it is one worth mentioning anyway. 3C. Aliens are here, but are so unrecognizable that we just can't see them for what they are. This subcategory would generally include both aliens who are so non-obviously thinking entities that we overlook them, like a big sentient rock that just parked itself here millennia ago to watch us, or an intelligent gaseous entity that floats around a cloud and communicates over the course of days by raining or emitting lightning bolts in a pattern we just haven't seen. It might even think it is talking to us and get responses because it rains on a drought-struck area, and we race around altering the place to grow plants in a certain pattern, and it's busy trying to figure out what those are supposed to say. When we're talking about really alien life, physiologically or psychologically, it's not hard to imagine that we just don't even see each other as alive, or it sees us but can't figure out how to talk to us. The problem with this is that once you abandon biology or logical behavior as a means of detection and prediction, you haven't got much of anything to work with, and maybe never actually will. There's no evidence for or against this, but you're basically left just shrugging and saying, could be, maybe. 3D. We are aliens. It's often been suggested that human intelligence is the result of aliens tinkering with early primates, or that we are a lost colony of aliens, and for that matter, the idea called panspermia, that original simple life might have originated in space and rained down on planets billions of years ago. This idea remains popular even with many scientists. The problem with the lost colony notion is that we share a ridiculous amount of DNA with other animals and plants on Earth. So we're obviously not direct descendants of theirs, except in a neopanspermia case, where they came to a desolate Earth billions of years ago and left behind some microbes which replaced life or started it and we descended from there. The intentional tinkering with smart monkeys option is essentially the alien astronaut option, category 3B, repeated over again. It's possible, but you have to wonder why. You have to wonder where's the evidence, and where do they go afterwards. As to panspermia itself, even if true, of which there's no real evidence, one would have to say, so what? If simple life hangs around space, raining down on planets, then life ought to be all over the place, and constantly reseeding itself if a planet gets sterilized by a supernova or a gamma ray burst. It doesn't change the Fermi Paradox except to make it worse. Like faster-than-light spaceships, if they can exist, it only exacerbates the problem of where all the aliens are. It does nothing to solve it. So that's Category 3. In Category 1, alien civilizations are rare. We mostly encountered the recurring problem of there not being any good evidence to support any given great filter or series of filters being so effective at preventing life from moving from basic self-replicating proteins up to interstellar technological civilizations. In Category 2, we kept tripping over the mediocrity principle and non-exclusivity of behavior. Here, in Category 3, it was always a lack of evidence from the one place in the universe we can actively gather evidence from, here on Earth. Each had its strengths, and each had its weaknesses, and you probably have a favorite or ones you think are particularly absurd and unlikely by now. Before we finish this video, though, we'll do some miscellaneous ones, some of which are pretty decent, and many of which are kind of absurd, or at least I think they're kind of absurd. You can judge that for yourself. It could be my bias. And if you're wondering what my view is, or my bias, I haven't personally locked into any of these as my official stance, but I favor Category 1B, that technological civilizations are just absurdly uncommon. I don't think any technological civilizations wipe themselves out terribly commonly, because I consider that to be kind of pessimistic. I think to go from inanimate, lifeless rock to modern human civilization has a huge number of hurdles in the way, and that they really do add up to make technological civilization so uncommon that even most galaxies have never had one yet. But I also figure there are probably a lot of worlds out there with simple life on them, so I'm not a rare Earth supporter. So let's get into Category 4, the miscellaneous items. 4A, technological civilizations hit singularities. A technological singularity originally just meant an ever more rapidly increasing rate of technology to hit a point, a singularity, where you have so much of it your behavior is just unpredictable. This has tended to get used just as frequently these days for describing some truly super intelligent computer mind a trillion times smarter than us. By intelligence that's basically godlike, it is assumed its motives are unknowable. Problem here, and I discussed this in the Dyson dilemma video in more detail, even if this does occur, we can still guess a couple motives. It will want more energy and raw material in order to achieve faster processing speeds and more memory storage, and this should result in interstellar expansion too, even if it's just a remote resource mining that's bringing back resources to the original homeworld. The other problem is again non-exclusivity. We already have way more computer power than we need to do interstellar travel, and while computer modeling plays a huge role in discovering new science and technology that would probably help us travel, it probably isn't absolutely necessary, so non-exclusivity wins the day. We already know many of us consider artificial intelligence or cyborgs or transhumans to be a little bit unnerving, the Frankenstein complex it's sometimes called. And those fears are not dismissed as superstition by experts, but rather considered very legitimate concerns. Presumably some other species will be, by the mediocrity principle, more or less concerned than us, and some might ban any computers that could run anything like a human-level intelligence. So beyond the fact that synthetic minds are not eliminating intelligent species, but just replacing them, there's no reason to think this always happens, and in such a way that makes them non-talkative or non-expansionist. So again, non-exclusivity. Although, again, unless you subscribe to the notion of social progress to a single inevitable type of behavior. 4b, the zoo hypothesis or quarantine. These are separate but basically the same thing, except the motives are a bit different. In the zoo hypothesis, Earth is, surprise, a giant zoo. They don't talk to us as not to interfere with our behavior, and have wrapped some sort of cloak of deception around our world so we don't see them. In quarantine, they view us as dangerous, but do the same thing. What's wrong with these? Well, they're a lot like Category 1C, in that they have us perceiving a false reality, where a group or individual with vastly more resources and intelligence is feeding us a line of bullshit. We can't prove it internally. There are other problems for the zoo hypothesis. We actually do interact with animals in a zoo. That's the whole point of zoos originally. Rare animals brought from far away that you can see up close. Note that this is not necessarily benevolent behavior. The other point of a zoo is preservation of those rare animals and appreciating them, and we do interact with them and don't consider it automatically harmful to do so. Also, humans don't need preserving. We're not uncommon, we're not rare, we're not endangered. For quarantine, one might ask what thing, or biological or psychological, they would be so afraid of us for that they would need to quarantine us, and why they couldn't just fix it instead of sealing in. Why, if they couldn't fix it, would they risk us continuing to exist and develop more and more technology to become a bigger danger? And this comes back to a problem I sometimes call the dumb alien theory, where it assumes behavior by aliens which, on examination, is either absolutely stupid or beyond evil. It's one thing to say, well, they might be watching us till we reach a certain technological level, preventing us from outside harm by others. Sort of like the Star Trek Prime Directive. Only problem is, if you're on the receiving end of the Prime Directive, you have very good cause to be beyond angry at the people who are enforcing it. Once the shock wears off of finding out they are aliens, you're going to think of all the members of your species who died from resource scarcity, disease, old age, and other things the aliens could have fixed by just saying, "Hi, here's some clean energy designs and all sorts of engineering and biological knowledge." And if they say, "Well, if you didn't discover it on your own, you wouldn't appreciate its dangers," you turn around and point out that you personally did not discover the atom bomb, nor in all likelihood did the particular alien you're talking to. And yet you are quite aware, as are they hopefully, that atomic bombs are dangerous. Space elves or space hippies who don't want us to don't want to talk to us because we abuse our environment, would likely end up accused of the worst hypocrisy, since they obviously have figured out how to do that, how to coexist themselves with nature, and could have spared us and our planet a lot of misery and a lot of extinct species by giving us a hand. 4C, interdiction. This is a lot like the zoo or quarantine options, but a little bit more plausible. In interdiction, various alien empires exist and enforce a no-contact policy with primitive worlds because xenocide is frowned on, and they do not trust each other not to try to either exploit primitive civilizations or to turn them against each other to their side. It is fairly plausible to believe that emerging alien civilizations, when they start bumping into each other, will set up trees of how far each can expand, and that could include leaving territory for other civilizations that are looking like they're going to emerge in the distant future, and they voluntarily accept limits on their expansion in exchange for the same limit on everyone else. There's a lot of parallels in human history for that sort of behavior, where both sides agree to be weaker than they have to be just to continue to react to each other peacefully. In such a case, it is plausible that emerging civilizations are interdicted from contact for those reasons, but while this is better than the zoo or quarantine solutions, it still suffers from all the problems in category 2D, the one where aliens are afraid to talk. 4D, self-imposed quarantine. This is the notion that they don't quarantine us, or even really hide from each other, but quarantine themselves. They all agree to stay on their homeworlds or not expand much because they've come to realize that they have massive destructive potential, and almost any interaction with any alien could spark wars. This suffers from a lot of the same problems as our sim locations cases, but its big flaw is in its actual strength. This theory assumes that aliens definitely do not socially progress towards an inevitable behavior. That they do things that absolutely disgust or mind-boggle each other, possibly enough to spark wars when they are in proximity to each other. And yet by giving that nod to non-exclusivity, it also requires they all still engage in an exclusive behavior of staying the hell away from each other, rather than, say, some of them being enthusiastic about genocide. It also requires the notion of irreconcilable differences between aliens. Not ones bad enough to initiate crusades to wipe other alien civilizations out, but enough for them to want to stay away from each other. And that does rub some people the wrong way, because they figure you should be able to have a dialogue with anyone. Just an example though, it is entirely possible you might encounter a peaceful and benevolent species which had high breeding rates and had to deal with that long before they ever got advanced science. And as a result of that, they routinely killed off 90% of their children. The equivalent to butchering everyone in 5th grade who didn't make the honor roll. And them being just as disgusted as we would be by that behavior, just disgusted by us because we actually allow kids who show any signs of self-destructive behavior or psychopathy to live, even though we have doomsday weapons they could conceivably get their hands on. They might find that insanely reckless. In such a situation, even though neither species wants war, they know that clashes or war might easily happen if they interact much with each other rather than just kind of ignore each other from afar with very little communication. 4E. Intelligent life got wiped out relatively recently. Replacements have genuinely not had the time to expand much. This is very popular as a solution in science fiction, but its big flaw, besides no evidence, is that it really couldn't be limited to just this galaxy. The universe does not end at the edge of the Milky Way galaxy, and even if some natural or artificial catastrophe had occurred very recently, too recently for other galaxies to have seen it and moved in on the fresh territory, we ought to be able to see them too, especially if they are engaging in multi-system Dyson swarm construction. You can see that from galaxies away as the stars just go dark. One would also have to ask what natural phenomena just killed intelligent life, or why someone would go around killing intelligent life and not bother leaving mechanisms in place to continue that process after the purge, and why they even let it get technological in the first place if they're continuing the purge. Why not, as we mentioned earlier, leave telescopes on every system staring at planets looking for any patterns emerging like roads or canals or pyramids and so on. 4F. Rim migration. It's been suggested that if most civilizations eventually go totally digital, then in order to deal with all their waste heats, they'd migrate away from the inner galaxy to the rim where it's colder. This would usually imply they built a huge supercomputer around their sun and moved the whole star system out to the edge of the galaxy. And this doesn't even require that much technology. All Dyson Spheres or Swarms are capable of being modified into interstellar vehicles by definition. This is called a Shikata thruster, and we discussed this in the Dyson Dilemma video. You could just let light seep out from one side and it pushes you in the other direction. Now, this is not even vaguely covert. You cannot and do not hide a Shikata thruster from the inhabitants of the galaxy it is leaving, because it's about as realistic to hide that as to hide an ICBM launch from a farmer living next to the silo. And since it takes a very long time, it's the equivalent of hiding daily launches for millions of years. To be fair, we could easily have missed that, with our current level of detection ability. But if this was a regular thing, it is one of the types of things we'd be able to see in the not-too-distant future. This also has the expansion problem. Unless they're only doing it for their home system, meaning they don't colonize other stars, then we ought to see millions of stars constantly heading out of the galaxy, and we wouldn't miss that here, even now. We'd see it even in other galaxies, where it would also be going on, which we actually considered a realistic possibility for ring galaxies like Hoag's object for a while, though that doesn't hold up too well to consideration. They've ascended. 4G. A popular idea in science fiction, and not too dissimilar to technological singularity models, is this idea that intelligent life eventually goes post-physical, becomes beings of pure energy, or just takes off for higher planes of existence. There's really not too much to say about this. It works just fine as a solution for the Fermi Paradox, especially if they get there before they go interstellar. But there's no scientific basis for it, and to me at least, it sounds a lot like options from category 1C. Or basically, it's very heavy on the mysticism, too heavy for my taste. Now, I told myself I wouldn't go through this video mocking any of the ideas, so I'm not going to say that it's basically New Age crap for people who don't like any of the legion of perfectly civil religions that are already around, and went in one produced by a sci-fi author instead. And the idea that a science fiction author would ever create a religion is, of course, pretty ridiculous. It's absurd. No one would ever convert to religion some author just cobbled together one day. 4H. We haven't picked a long-distance carrier yet. This one was funnier back when people actually had long-distance carriers for their phones, and we had long-distance phone calls. But it also goes by the term, we need to put a deposit down to get the signal unscrambled. With television, you will get a signal unscrambled for cable. Right? Really just a variant of 2A, that they have mouths but we've not got ears to hear them. Except that by embracing the idea that we're not getting reception because we haven't picked a carrier or paid to get the signal unscrambled, it gets my stamp of dumb aliens. Because if you're selling a product, you have to be an utter moron not to advertise the product. Though it matches up decently with interdiction or self-imposed quarantine solutions. It's out there, you can get it, but they don't advertise because they're not allowed to, or they think it's bad manners. It still has all the other problems associated to non-exclusivity or mediocrity principle, though. 4I. Made out of meat. If you're a big Fermi Paradox follower, you're probably wondering when I was going to get around to mentioning Thierry Bisson's short story, They Are Made Out of Meat. Since I've just mentioned a lot of the other popular weird ones, and the answer was nearly no, that it was covered in Category 3C, aliens are unrecognizable, and I always consider this one to be kind of stupid anyway. The notion of aliens that couldn't recognize humans as intelligent because we're made out of meat trips right on the starting line by assuming they obviously know what the hell meat is, a material used to allow animals to move that implicitly requires a functioning nervous system. If they didn't know what meat was, they wouldn't call it meat. They'd call it bundles of protein and be shocked things used it for locomotion. It's also implied they've encountered plenty of other aliens before, and you really would expect locomotion to be a common trait of intelligent life, and doing it through causing contractions via electrical stimulus would probably be one of the more normal routes. I saved this one for last because while I get any attempt to impress an audience with the sheer alienness of something can fall flat on its face in deep examination, I really have no idea why anyone seems to make so many Fermi Paradox solution lists, including this one. And yeah, we are done. I'm sure I missed a few in there, but if you're newer to the Fermi Paradox, that covers most of the bases. The companion video, Dyson Dilemma, is also worth watching if you've made it this far without being bored to death. I hope you enjoyed this, and thanks for watching.